So my spine now is stretching, but one of the things that it is not doing is allowing the spine to lose its volume as it is stretching. What I mean by that is that when you have an object stretch, just like the principles of animation, you say that by stretching it, its mass should change, or better, its volume should change because the mass gets stretched as well. So we're going to add an additional number of nodes to manipulate the stretching of that torso. So in order to do that, we're going to start by renaming that multiply divide node that we created. So I'm just going to go and double click on it. I'm going to call it stretch x underscore divide, and that's called the stretch x because it is stretching the x attribute or node for each join. Again, the x is because it's going along on the x direction of the orientation of the specific join. And I'm going to go now, I'm going to create a second node, and a second node that is going to be working from that. And I'm gonna just, in order to that, I'm gonna just press here. I could go to the hyper shade, but I could also, if I press the tab key generates this little space there, so I can go and type multiply, and right away the multiply divide node appears right there. So create a multiply divide node. This one I'm going to rename it. I'm gonna rename it stretch Z and Y. I'm gonna call this stretch underscore Z underscore Y underscore power. And the reason I'm giving it that name is because we are going to use in this moment a mathematical operation to provide the effect of when the object loses, or better, when the object is stretched, the mass gets shrunk. For that, you need to use some math, or mathematical equation that will do it. I'm not a mathematician, so I'm not clear exactly how it works, but what I can tell you is that what we need to do is we're going to use this formula to make it happen. So we're going to have a division that is going to have a square root division of each one of the scales y and scale z, so that we can try to make it work right there. Let me try to see if we can just get out of the PDF now. Let me just pause my video for a second. Okay, and let me just move this out of the way. So what we're gonna do there is we're going to use this stretched power node, and we are going to make out of it the operation. So the first thing is going to do is, with out of the formula, we are going to take the lower part of the formula on that form, and we're going to just do the power part of it. So let me try to get that out of the way here. So I'm going to select on this guy, and what it's going to say is that this guy is going to receive the output in X into that input in 1, so that I'm going to grab the output of this guy. I'm just trying to grab it right here. Try to get the output of it right here. Not letting me do it. There is my output. So I'm going to grab the output of this guy, and I'm going to just grab it. Let's see if we can do that. I'm going to try to connect it here to the input in 1x. So that when you see here, it comes into this. And this option here, I'm going to use the option of power, because we're creating a form for the section of the formula that uses the square root. But because it's power, we want to be half of a power, because that's what a square root is. So I'm going to say 0.5. So it is the formula is taking the stretch divide value of the spine of that object, and I'm going to connect it to the lower part of the formula. Then we are going to go and create a second. Let's bring this guy back here, and I'm gonna just get a second multiply divide. So I'm gonna get that one more time, multiply divide right there, and this one I'm gonna rename it stretch ZY divide, stretch Z underscore Y underscore divide. So again, going back, this is going to do the division component, the prior formula, the ZY power did the power component of it. The second one is going to do the whole formula, which is the division, the 1 over the square root of scaling x. So what I'm going to do here, I'm going to just make this one is going to be a division, and what it's going to do is going to receive from the output of this guy. I'm going to connect the output in x. I'm going to connect it, in this case is going to go to the input in 1, to input to x, because it needs to enter into the lower part of the formula, and on the top part of the formula I'm going to put the number 1. So again, the output of this one, the power, which is that part of the formula, is divided by 1. So there is, right there, is dividing number 1. So what that makes is that now I can go and reconnect this guy to all the joints. So let me call my my activity, not my activity, my connection editor. I could do it manually here, just grabbing it one by one. I'm going to, but I'm going to do is do it with the connection editor. It's a bit easier for me to do the connection editor. So I'm going to just go to my connection editor. And again, I need to get the output of this guy, the output in X. It's going to connect. I'm going to avoid the root because the root I disconnected it from the previous video. So I'm going to just do it to the belly first. And in this case, that output is going to connect to the scale again, but this time will be the scale in Y and Z. Let me do the next join. Scale in Y and Z. You see the scale in X already taken, so that way you cannot do it. I'm going to do the low chest. And then the chest. And the sternum. And the collar. So now I have made the connection there. Let me just close this, so that when I stretch the spine, the body will lose its thickness, so the volume gets thinner and thinner the longer you go. Again, this is not a completely stretchy rig, but it allows you to have a little bit of exaggeration on your character. Okay, so I'm going to just stop it right there. So let me just save my file, and we continue in the next video.